Hello, I'm Bonnie, and I'm going to be explaining to you a spooky pattern I found in the multiplication tables. First off, we're going to start with as quick of backstory as I can make it. So I am not a math person, despite having found what this video is about, but you might be doubting that, but I can prove it by saying that when I found this, I was repeating college algebra because I had gotten a high enough grade to graduate, but I hadn't gotten a high enough grade as a prerequisite to get into the post-baccalaureate teaching certification program that I went on to be in. So I was repeating algebra. I had math on the brain, and I was laying there thinking deep thoughts instead of sleeping, as you do at like midnight when you're like desperate to get to sleep. And all your best thinking, of course, happens then. And I started thinking about the fact that when my mom was helping me with homework, when I was learning the multiplication tables, she told me a trick that she had learned in school, which was that you can make sure that your answers are right to the 9 times table, because the digits of each answer, if correct, will add up to 9. So you know you're right when you get 9 times 9 equals 81, because 8 plus 1 equals 9. And you know you're right when you get 9 times 8 equals 72, because 7 plus 2 equals 9. Even once it's 3 digits, you just add each digit together until you get a single digit. Similar to numerology, which I remember from teen magazines when I was in high school. You add numbers together to get a single number, and then that's supposed to say something about you. But I was wondering if that was the case with any of the other multiplication tables, or if 9 was just the oddball. And so I started thinking about other ones, and I found out that there is, in fact, a pattern, not just to 9s, but to all of them. The first one I thought of to test and see if 9 was by itself or not was the 2 times table. And I have that up on the screen along with a 9. I'll leave the 9 on there, but as I go through, we'll loop back around to 9. But for now, let's talk about the 2s. So obviously it starts 2, 4, 6, 8. 2 times 1, and the numbers on the left you multiply by the numbers on top, and that's the answer. So 2 on the left times 1 on the right, you get 2. 2 by 2, you get 4. That's how that table works. So 2, 4, 6, 8, pretty obvious. But 10, 12, 14, 16, 18, you get 1, 3, 5, 7, 9. And then 20, 22, 24, 26, which is off my chart, but you get 2, 4, 6, 8. So the pattern in the 2 times table is even numbers and then odd numbers, alternating on to infinity. You want to multiply however big of a number by 2, you're going to get its corresponding place in that pattern on for forever. So again, the pattern in the 2 times table is evens and then odds, evens and then odds on forever. So then I thought, well, that's kind of odd and kind of cool. Let's think about all of them. So then I thought about the 1s timetable. And obviously 1, 2, 3, 4, 5, 6, 7, 8, 9 but then what happens after that is it repeats. So the pattern in the 1 times table is 1 through 9, and then 1 through 9, and then 1 through 9, and then 1 through 9. On to infinity, adding as many digits together as you need to get one single digit. It will be 1 through 9, repeating. The 3 times table is 369, 369, 369, 369. So 369 repeating on into infinity. And that was the first one where I thought, wow, this is really cool. And wow, I never would have realized this until I actually started adding those digits together. The 4 times pattern is, on the face of it, you don't see it right away, but it's 4, 8, 3, 7, 2, 6, 1, 5, 9, 4, 8, 3. So if you start with the first number, it's 4, 3, 2, 1, and then 9, 8. You start over again. So starting with the first square, every other one is decreasing 1 number. And then if you start in the second spot, it's 8, 7, 6, 5, 4, 3. So alternating decreasing numbers. And where the 4 times table decreased, now looking at this one, the 5 times table is 5, 1, 6, 2, 7, 3, 8, 4, 9, 5, 1, 6. So starting with the first one and skipping 1, it's 5, 6, 7, 8, 9, 1, repeating. Starting in the second one, it's 1, 2, 3, 4, 5, 6, repeating. So whereas the pattern in the 4 times table is alternating decreasing, the 5 times table is alternating increasing. Weird, huh? And when we look at the 6 times table, again, we see a pattern from before with some variations. So 639, 639, 639, 639, repeating on towards infinity, where the 3 times pattern was 369, 369, 369, 369. So 4 and 5 are related, but kind of opposites at the same time. And 3 and 6 are related, just with the numbers switched around a little bit. Now we get to the pattern in the 7 times table. And it is counting down odd numbers and then counting down even numbers. So 7, 5, 3, 1. And then 8, 6, 4, 2. And then 9, 7, 5, 3, 1. Repeating. And we've already found 2 similarities between 4 and 5 and 3 and 6. Well, what about 2 and 7? And sure enough, 2 and 7 are swapped. 2 is even and then odd counting up, and then 7 is alternating evens and odds counting down. And now let's look at 8. 8 is 8, 7, 6, 5, 4, 3, 2, 1. 9, 8, 7, 6, and then continuing on 5, 4, 3, 2, 1, repeating. And we've already been finding pairs. How about a pair for this one? And the pair for this one is 1. So 1 is 1 through 9, counting up, repeating. And 8 is counting down, repeating. So 1 and 8 are opposite pairs. 2 and 7 3 and 6, and 4 and 5 are pairs. So 1 through 8, each of them has a pair that is kind of their opposite as well. And then we get to 9, and 9 is just 9 repeating. 9 is the self-absorbed oddball, I guess. 9, 9, 9, 9, 9, 9, 9. So what happens beyond 9? Well, we get to 10, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly like the 1 times table. Exactly like it. 1 through 9 repeating. What about the 11 times table? 1 and 10 are the same. Are 2 and 11 the same? And yes, they are. 2, 4, 6, 8. 1, 3, 5, 7, 9. 2, 4, 6, 8. 1, 3, 5, 7, 9. Exactly the same as 2 is. So 2 and 11 are twins, are 3 and 12, and 3 and 12 are twins, yes. 3, 6, 9, 3, 6, 9, 3, 6, 9, 3, 6, 9, repeating. So if you were going to pause on a screen, this would be the screen to pause on. It's the zoomed in the most, it's clearest the most, and it goes the furthest on. What I found, the pattern is 1 through 8, with patterns that match up. 1 and 8, 2 and 7, 3 and 6, 4 and 5, and then 9 being repeating 9s. And then the same thing repeats no matter how far on you go along. But 10 is the same as 1, 11 is the same as 2, on through 17 being the same as 8, and then 18 is a string of 9s repeating. And every 9th one will be a string of 9s repeating, with the preceding ones being the same as 1 through 8. And this pattern repeats and repeats and repeats. So here is my theory, even though I haven't gone on far enough to prove it, but I have a feeling it's right. If the digits of the multiplication table you're doing, so say the 10 times table, add up to 1, it's the same pattern as the 1 pattern. If the digits add up to 2, so 11, 1 plus 1 is 2, it's going to follow the 2 pattern. Similarly, 18, 1 plus 8 equals 9, so it follows the 9 pattern. So say you were doing the 372 multiplication table, would you add up 8, 9, 10, 11, 12 equals 3, and it would be the same as the 3 pattern? I think yes. I haven't done it, but I think yes. I think you add together the digits of whatever multiplication table you're doing, and it equals 1 through 9, that pattern. Crazy! Since I had it in that Excel format, I started seeing other patterns which I had never seen before. And I didn't say in the beginning, but this was probably, I don't know, like I said, I'm bad at math, but I'm 40 now, and this was after I'd finished my bachelor's degree in English literature and was going back for teaching certification. So I don't know, like 15 years ago, that I've had this and known about this. I tried to tell 2 people about it. I tried to tell my algebra professor at the time, and he kind of briefly looked at it and then told me, oh, there's patterns in everything in math. Math is really amazing, and let's get back to algebra. I was like, yeah, this is an amazing pattern. Does anyone know about it? That was a thing because I'd never heard about this before. I tried to Google it. I never found it. I have a friend who's was a biochemist at the time and had taken a ton of college math. Like, I literally just took algebra. And I showed it to her, and she said, no, I've never heard about this before. None of my math teachers ever talked about it. I've never seen it before. That's really interesting. I'm not sure what you should do with that, but it's really interesting. I mean, when I take IQ tests, I always test highest in spatial logical. I can see patterns really easily. I have a really good mind's eye. I can rearrange things. That's the only thing I can say for how someone with basic college math found this. But getting back to the pattern, if you look at it diagonally, which I had never seen before putting it into the Excel spreadsheet, there is a pattern that leads up to a number, the number is doubled, and then it leads down. So 14977 and even another diagonal and the same kind of pattern. 36299 although the 3 is off the edge there, but it would be 3. And the other diagonal, 39466 So even looking at the diagonals, there are patterns in that as well. So I feel kind of free having done this video and putting it out onto YouTube. I felt like a crazy person that's known this thing, that like that quote where people once in a while stumble across the truth but dust themselves off and continue on like nothing has happened. So I would love your feedback on any comments. Had you come across this before? What do you think about this? Do you think this should be a part of teaching the multiplication table as kind of a check for multiplication? I don't know. I would love to hear your comments, your thoughts, your feedback. Let me know your thoughts. And thanks for watching.
Yeah.